Let's start the recording. So, lesson 6.3, we're talking about specifically parallelograms. And remember in lesson 6.2, we figured out the properties of parallelograms. That, by definition, a parallelogram has opposite sides that are parallel, but we also found out that not only are opposite sides parallel, opposite sides are also congruent. We also found out that opposite angles are congruent. Consecutive angles are? No. No.
Supplementary.
Yes. We also found out that the diagonals do what to each other? What?
Split in half. Divided by 2.
Cut in half. Give me one word that means cut in half. Bisect. Very good. Well, in lesson 6.3, we're going to kind of use those properties that we learned in 6.2 backwards. Such as this. As we said, a quadrilateral is a parallelogram if both pair of opposite sides are parallel. That's the definition. Other ways to determine if a quadrilateral is parallelogram. We start like this. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. It's a theorem. Both pairs are congruent. Then it's a parallelogram. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So it's pretty much everything we learned in 6.2 going backwards. Because in 6.2 we said, okay, if a quadrilateral is a parallelogram, then opposite angles are congruent. In 6.3 we just turned it around. Wait a minute. Didn't we have something in the first trimester that we talked about when you switch the hypothesis and conclusion around? My former college professor used to call it the old gym shoe special.
You had to take geometry in college.
I did. I got a D in it.
You're teaching it.
I am.
How about Miss
Another time.
Yoshi?
Okay. All right. So, basically, these four theorems are everything we learned in 6.2 backwards. Okay. Both pairs of opposite sides are. If both pairs of opposite sides are congruent, then we can conclude that the quadrilateral is a parallelogram. Both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. The diagonals bisect each other. Quadrilateral is a parallelogram. One pair of opposite sides is both parallel and congruent, then the quadrilateral is a parallelogram. Okay? So basically, instead of knowing it's a parallelogram, and hey, that's true about all this, now we're going to have to look and say, can we show it's a parallelogram?
Nice, I like how
Determine whether each quadrilateral is a parallelogram. Justify your answer. Why is number one a parallelogram?
because two sides are congruent.
Correct. I need to hit this one.
I thought both sides, both pair sides had to be.
By definition, yes. But by theorem, since one pair of opposite sides are both parallel and congruent, that means it's a parallelogram. Why?
Both pairs of alternate angles are congruent.
Correct. You guys okay with my abbreviations? What is RE? R? A-R-E?
That looks like a D.
It says the
Is that better? You're welcome. What about number 3? No. We don't have enough. Okay? You have one pair of opposite sides, but if you're going to use just one pair, you have to prove not only are they congruent, you also have to show that they're parallel. What about number 4?
No,
Why not?
because there's not at least one pair of sides that are parallel. Or it doesn't tell us that they're parallel.
Agree, but if you look back through the theorems we wrote down,
All the sides.
both pairs of opposite sides are congruent. Let's examine for just a second here. Number 4. Suppose, I need a name. Yes, Nate.
CHOP.
Okay.
Nate? CHOP.
Suppose we have parallelogram, or this quadrilateral Nate. And we're given what we're given, and I drew in segment AE. Complete this for me. Triangle NAE is congruent to triangle TEA. Why?
Side, side, side.
Side, side, side. NAE
What'd you say, Daniel?
congruent to ETA, or TEA, sorry. Name these correctly. Why?
Oh, okay. I thought you were getting something.
Nope. Okay. The two triangles are congruent because we have side, side, side. These are given. These are given. Why is EA congruent to itself?
Because it's a
Not a weird theorem, it's a name. Nope.
bisector.
No. Say it. Yeah, it's reflexive. EA is congruent to itself because it's reflexive. Well, if that's the case, then can you guys agree with me that angle NAE is congruent to angle TEA?
Yeah.
Why?
Alternating theory.
Do you know lines are parallel?
Yeah.
How do you know lines are parallel?
All the triangles, all the lines and polygons congruent.
Yeah, the triangles are congruent, but does that prove that the lines are parallel?
No.
So what other reason can you tell me why is this angle congruent to this one? CPCTC.
Slap him right in the throat.
Would you guys also agree that angle NEA is congruent to angle TAE?
What? Angle what?
Angle NEA,
That's really stuff.
I know. Angle NEA is congruent to angle TAE.
Yeah.
Why? Very good. But, guys, since these two angles are congruent, what's true about NA and ET? We already know they're congruent because that's given. Why are they parallel? The angles do match, and they're what special pair of angles, Jonas? Not quite. Yeah. We've just shown that alternate interior angles are congruent, thus lines are parallel, which means these angles are also congruent by CPCTC, so we've shown that these sides are parallel, thus we've shown it's a parallelogram. That's why the theorem works. All right. Let's move forward.
Yeah, that's nice. Nippy.
We can also use a little coordinate geometry to determine if a quadrilateral is a parallelogram. We might need the slope formula today. y2 minus y1 divided by x2 minus x1. The ratio, the change in y over the change in x. You guys ever seen it written this way?
No.
Does anyone know what that symbol is in front of the y and x? Does anyone know what letter that is in front of the y and x?
A triangle.
It is a triangle. What letter is it?
Zero.
No.
Wait, letter or number?
Delta.
Delta. It's a Greek letter.
How's that D?
It's not a D. It's delta.
Starts with
Yeah. Alpha, beta,
Charlie.
theta. Okay. The triangle is the Greek letter delta. Delta in mathematics and science means change in. So some people will abbreviate the slope, maybe when you get more upper level mathematics, as delta y over delta x. Change in y to change in x. You also may have to know the distance formula, which I see someone wrote on the board for me here in the last couple days. Square root of that, or excuse me, yeah, square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared, quantity squared. Of course, the distance formula really came from the what theorem?
Midpoint theorem.
No.
Uh,
No. Where else do you have something where you square a couple things and add them together and
square roots.
no?
big one is
Quadratic
like
formula.
AB squared plus
Quadratic formula.
Not the quadratic. Kind of on the right track with the big one. Not FOIL. Take a look at these examples. Graph each quadrilateral with the given vertices. Determine whether the figure is a parallelogram. Justify your answer with the method indicated. Tina, you got this? Did you print these notes off?
Yeah.
Okay, so you got these coordinates for me, right?
Yeah.
Cool. All right. Whoa. Different background. How about mediums? Okay. Courtney, what's our coordinates for these points?
0, 0.
Thank you.
S is 7, 4. And Y is 4, 0.
All right. Plot those.
Use the top
You
of
use
it.
the other end.
Oh,
Yeah.
shut up.
The pen, use the stylus.
At 0, 0.
Okay?
3, 4.
Okay.
I'm going to count. What the heck? There.
Thank you.
Stick a dot up there. 7, 4.
Didn't even question that.
All right. The directions said we are to use the slope formula to prove that this is a parallelogram. Well, if we use the slope formula, what's the important thing that we know about slopes and lines? If we want to prove it to be a parallelogram. What? How do we prove what's congruence mean, Clark? Same what? Length. So would slope help us to prove same length?
Yeah.
How?
Rise over something.
How does that prove length?
You just count how like far it goes. how sideways it goes.
If I want to know how long something is, I don't need to know its slope. I need to know its. See if they're not going to cross, they keep on going. Yeah, if I need to know how long something is, I don't want slope, I want distance. How can we use slope to determine whether or not things are parallel?
If they had the same slope there.
If they have the same slope, they're parallel. Correct. So, here's P, here's Q, here's S, and here's Y. Ladies and gentlemen, what's the slope of QS? Remember, for slope you have to do y minus y, 4 minus 4, over 7 minus 3, and now here's 0. And you're right. What's the slope of PY?
0.
What's the slope of SY?
2,
No.
3, 4.
3, 3. 4, 3.
Well, okay.
4, 3. It's 4, 3.
If I look at SY, guys, which ones are the Y's? Which ones are the X's? So it would be 4/3. Finally, what's the slope of PQ?
Same thing.
How do you know?
Because it's a parallelogram. Because if it wasn't a parallelogram,
Do you know it's a parallelogram, though?
well, I just assumed.
Ah, but you know what they say about assuming.
I'm always right.
Okay. Remember, you can't assume that it's a parallelogram yet. You're trying to show it's a parallelogram. So if you have the slope formula, you have to show that both pair of opposite sides are parallel, which means you have to show that both pair of opposite sides have the same slope. So PY and QS both have slope of 0. PQ and SY both have slope of 4/3. Yes, it's a parallelogram. That's how you're going to use the coordinate geometry. Okay? If all you can do is slope, prove that they're both parallel. Parallel lines have equal slopes. Courtney, what's the next one say?
S is negative 2, 1.
Okay, hold on.
Ooh, that's not a straight line at all.
Continue.
R is 1, 3.
Yes.
T is 2, 0. Z is negative 1, negative 2.
And what formulas are we given?
Distance and slope formulas.
Distance and slope.
Can I graph those?
Nope, I think Hummel's going to graph these. Since she was making so much fun of yours, let's see what she can do.
Yeah, it's not that easy.
Okay.
It's an upside down head.
Is that negative 2?
Like right
First
when
one?
you raise it.
Okay. Oh. Negative 2. Oh, that's really small. What? It's like it's not drawing.
What is it?
It's like not
Yeah,
drawing.
it's doing something with 3D thing.
It says select all.
Select all.
Oh, just click, hit somewhere not on.
Down every single thing.
Like not where that is.
a dot, it'll like think you're like copying and pasting something.
Oh,
There you go.
okay. Stop this.
Is that all? You only got one dot up to this.
Okay, there's that one.
Okay.
Where's your dot way down in the fourth quadrant? Is that the fourth?
Negative 2, 1, 1, 3.
Oh my gosh.
1, 2, 0.
2,
Here's 2,
7,
0.
negative 1, negative 2.
That's atrocious.
It's, I don't like this. Okay.
Awesome.
I don't like writing on my face.
Okay. We have to prove that this is a parallelogram. And the only thing we can use is distance and slope. Okay? Well, we can go back to the last theorem that we talked about. If one pair of opposite sides are both what?
Congruent.
And? Parallel. Then we can prove it's a parallelogram.
Yep.
So, what I would do with this, S, R, T, and Z. Which sides do you wish to work with?
We're gonna go with the.
Sides need 2 letters.
SZRT.
RT.
SZRT.
All right, so let's work with SZ
It's a crazy looking
and RT.
It's like an E without a top.
Let's find their slopes.
-1, 3. -3, 1. -3, 1.
SZ, okay. Slope of RT.
Same thing.
It is rise over run, so you can simply either, if you don't want to use the formula, you can just simply look at the graph. To get from S to Z, you'd go down 3 and 1 to the right. R to T, down 3 and 1 to the right. So we've satisfied the first part of that theorem. One pair of opposite sides are parallel. How do we know they're parallel? Because their slopes are congruent. Slopes are the same. Now let's find their distance. Well, here's the nice thing. Notice how in the slope formula, it's y2 minus y1 over x2 minus x1. And notice in the distance formula, it's still y2 minus y1 and x2 minus x1. So instead of me doing this whole math, I'm just going to cheat. -3 squared plus 1 squared. Guys, what's -3 squared? 9. 1 squared. 9 plus 1, so there is the square root of 10. So SZ is going to be the square root of 10. Guess what? You got the exact same numbers. Is it a parallelogram? Yes, because one pair of opposite sides are both parallel, proven by the fact that they have the same slope, and congruent because they have the same distance. That's how you do lesson 6-3, guys.
How do you use that graph?
Didn't know it was there. Finally, yes, you may close the door. We can use the conditions of parallelograms to find missing values that make a quadrilateral a parallelogram. Such as this. Find x and y so that each quadrilateral is a parallelogram. So you're going to be setting up and solving equations.
2y equals y plus 8.
That is correct. We'll start with that. 2y equals y plus 19. What other equation do we need for number 8?
2x minus 8 equals x plus 16.
Correct. 2x minus 8 equals x plus 16. I'm assuming I can let you guys solve for x and y from there, Clark? Okay. Okay. What would you set up for number 9, guys?
Y plus 3.
And then 3x equals 4x minus 3.
Correct, because diagonals of a parallelogram bisect each other. Et cetera, et cetera. I think you guys got this. Do you understand it better now that you've seen it with me?
Yes, thank you.
Okay.
There were some problems where there was like an x and a y and
You may have to do a little system of equation work there. Okay. All right.